Hi there. So in this lecture, we are going to perform phylogenetic analysis using IQTree. So IQTree is a bioinformatics software for phylogenetic and phylogenomic interference. It is available as a web server. You can use it as a web server. For example, if you type IQTree, the Google will take you to the IQTree websites and you can use it as well there. But it is also available as standalone tool. So in this tutorial, we are going to see how to use it on Ubuntu. So first of all, you have to prepare the system, sudo apt update, sudo apt upgrade, you can use it. After that, you have to download the IQTree. So first of all, we will move to the downloads repository. For example, we are in home and cd downloads. CD downloads will take us there. After that, to get the software, you can visit their page as well. And if you don't have to visit the page, you can just get this command that this file I will upload it to the server as GitHub as well. And you can type this command and download the application. For example, if we type in the command and we see that the file is downloaded, and if I maximize this window and ls, there is a file. Sorry about that. So here is the file iq3 linux.tar.gz. After that, we have to unzip this file. So we are going to use the tar file to unzip this, and a new directory will be created named iq3 6.linux. So we will see if we have this repository. For example, here is the repository that I have already extracted, so it doesn't take any time. And after that, we will see there are a bunch of files that are here. So here you will find the executable file name iq3. Move it or copy it to the user bin directory so you can execute it from anywhere you want. So note, the iq3 can easily be run by typing iq3 in the terminal. So here, if we, after extracting it, moving to the bin file, if I see, let's just see, there is a application name iq3. So we don't have to do anything. We just have to type iq3 anywhere in the terminal and it will shows us iq3 multi-core version for the Linux operating system developed by these researchers. Command line example is here. You can infer maximum likelihood tree. You can perform the model founder. You can combine model founder with the tree search and ultra bootstrap test. You can perform edge link proportional model as well, and you can do a lot of things. But if you need help with iq3 and perform some advanced level research, you can type iq3/h and it will give you all the options that are built in it, and you can use this to perform a multiple sequence alignment, and after that multiple sequence phylogenetic analysis. So for that you need a sequence file that is aligned. So the model founder of the IQ tree helps you find the best fit model. It supports several substitution of DNA, protein, codon, and binary alignment. So you have to align your sequences just as I told you in the previous tutorial that we have aligned the sequences using the cluster omega, and then we have saved the alignment in the FastTree file. So if I can show you in this tutorial as well, if we move to the sequence alignment tab and see here, there is a file which is out aligned.fasta. Here are all the sequences that are aligned. So we have the aligned sequences. Now we need this command to get the tree results. So for that we need aligned sequence .fasta file, and then we have a model name. So what is model? So model refers to such as TME, IJSA, JSA, WAG, and so on. You can find and select the model from their website that I have also given here. So if you don't know the appropriate model, using the following command can test all of the models here. So let's test these one by one. So we copy this command and move to terminal and paste it here. So what we need to remove this file name and type in our own, which is out_align.fasta. So here it is creating the initial prismony for the phylogenetic tree, and it is checking all the sequences. So the sequences have some gaps, composition is passed, and their p-value is preserved as well. So there are 77 sequences that are being used, 100 sequences that are being used, only which 0 sequences fail the composition. After that, the model finder will test 456 protein models, and it will apply all of them and gives you the result that is best for it. So here it is testing all the models and generating the phylogenetic tree result. So we are just going to wait until it shows us the results, and you can use this to get the results as well. So if you want to, I will also upload a tutorial of iTool which use this IQ tree file to annotate the result and make a beautiful phylogenetic tree. And if you want any other analysis in the bioinformatics, for example, you want protein structure and anything on the Linux operating system, you can just tell me in the Udemy inbox, and I will try to upload the tutorials of that as well. So this is the I think end of this tutorial series for Bash. I will include some of the introduction of the Linux and Unix, which will not be compulsory, but I will also include some higher level analysis like variant calling and NGS data analysis in the upcoming sections, so you can use it easily on your Linux operating system. But if you want any other analysis to be done, you can tell me as that. I will try to do that, and then uh, tell you the results. So it will generate some results for us, and it will create some files that will include the best model and the results for us. So it is creating the some likelihood and optimizing the tree set, optimizing the candidate set, and then it will better tree that will be built here, and it will give us that results. So better tree is being found out in the tree set. So let's just see what it creates and how much time it is going to take. So it is almost taking around 1 minute to do the uh, sum of the operations, and better tree is now being found. So let's just see if it creating any results. So if we move to the downloads folder and second folder, so here are all the uh, sequences that are all the files that are being generated. Sorry, not sequences. So here we will see that better tree is being found and their iteration is now being done. So we will wait when the analysis is being done, and we will get our file with the results and with the tree. So it is now taking time, so let's just wait while it's done. So I already have done this, and I will show you the results. We move to downloads and then move to the alignment. Sorry, it should be a folder alignment. I will see that in the directory. So if we move to the downloads, there should be a it to move to the home. Yes, here is the alignment folder. Let's just see if this is done. No, it is being done. So there is should be a folder name alignment. So here it is, and here is all the uh, uh, analysis that is being done. So there is output alignment dot faster. There is a faster file. There is faster dot log file. So here was our sequence file that was already aligned. So here we will see output dot alignment dot faster dot iq tree. So we will try to read this file output dot alignment dot iq tree. So here we will see it has used all our sequences and the tree is unrooted through this taxon and the maximum likelihood tree was created, and here are all the uh, scores, BIC score for the best model founder. So the best fit model was JJT-R2, and sequence alignment was also done. So you can use this. So I have already used it and generated the results. So you don't have to wait. So tree, here is the tree, and here is the tree in the NAVIC format. So what is the NAVIC format? So the result is being generated by the IQ tree considered in two forms. So there is a unrooted tree on the above, and there is a tree in the NAVIC format. NAVIC format is format which is generated when you get the result in your which you get the result from IQ tree. So you can use this NAVIC format to annotate your tree and make uh, some of the excellent phylogenetic trees that you see in the research. So, for example, if I can show you in my research as well, so here in the file folder, if I can show you some of my research papers that I have been doing, and some of the phylogenetic trees that I have created using IQ tree, and by using that NAVIC format and annotating in on the I tool, I have created some of the let's just see. So here is the phylogenetic tree that I have created using IQ tree and then annotated on the I tool. So I will include a tutorial for that as well, how to use the I tool for your research papers, and you can use that as well. So you have to use the NAVIC format. So the NAVIC format will be generated. For example, our analysis is also done and the IQ tree report is written as out align foster.iq tree. So if we copy it, for example, if we copy our out file name and read it, and here we will see we have the tree in the NAVIC format. So here is the tree. So we can use this tree as well. So we have gotten the similar result just like before, just like I showed you. Here is the maximum likelihood tree. Here are all the models. So the best fit model is JGT R2. The here is the unrooted maximum likelihood tree. So that's it. So you can use this IQ tree to create some of the beautiful uh, trees here. You can use for your own research and things like that. I will include this tutorial as well. So that's it for this lecture. So if you have any other suggestion regarding this course, if you need any other analysis to be done, you can always hit me up on the Udemy, and I will try to explain and include that lecture as well. Thank you so much for taking this course. I hope you have enjoyed the course and you will learn a lot more in the upcoming sections as well. So thank you so much.